So, yesterday we started thinking about how we could calculate the area of weird polygons, and now we're taking that beyond to see how can we use dissection and boxing methods to calculate the area of a circle. The weirdest of shapes because it doesn't have any straight edges at all. First, we got a super weird polygon. And I had people who were like, oh my goodness, this isn't even, what am I going to do? Well, that's where it's helpful to do a very clear dissection. So yeah, that isn't even because this edge right here is 3 centimeters, which means this part needs to be 3 centimeters as well. Well, we can dissect further, and now I have 3 rectangles. So I'm going to do my smallest rectangle as 1, my middle rectangle as 2, and my largest rectangle as 3. So I've got to figure out what is this length here. This comes up to 3, and that goes all the way up to 4. That tells me that this would have had to be 1 centimeter, because 3 plus 1 would give me the length of 4. So I have a 1 by 4, 1 times 4 array or rectangle, which means that this area is going to be 4 square centimeters. Down here I have a 3 by 9, which is going to be 27 squares. And over here I had 5 centimeters on the side plus 1 more. So this is actually 6. 6 by 11 is going to be 66 square centimeters. So to find the total area, I would need to add 66 plus 4, which is 70, plus 27, which is 97 square centimeters. So that was about as weird of an all rectangle funky polygon you can get. So then how do we apply that to circles? Ooh. People had some different strategies that I liked a lot. Some people thought about boxing it in. Just draw a square around that entire circle. And they could get an approximation because they could approximate that the area of the square is going to be the length by the width. 1, 2, 3, 4, 5, 6, 7 by 7, which would be 49 squares if you didn't want to count them all. But the circle doesn't take up the entire square, so I'm going to have to take some stuff out. I would need to take these 4 parts out here. I notice, though, that if I do something like this, all 4 parts are the same. So if I figure out how much to take out right here, I can just do that 4 times and take that out. So the whole square is 49 squares, small squares. Here, I'd say I have 1 full square, a partial square, a smaller partial square, a partial square, and a smaller. Well, I can put these 2 together and say that's approximately 1. These 2, it's approximately 1. So 1, 2, 3. This entire thing would be 3 that I need to take away. And I have 12 of those. So minus 3 more, 3 more, 3 more. So that's, 4 of those, which would be 12 squares total that I'm taking away. So that means I'd say this is approximately 37 squares. For a diameter of 1, 2, 3, 4, 5, 6, 7 across. So my diameter is 7 and my area is 37. And we did this a lot. Every partnership did 2 and they were different from each other. And we looked at some class data that ended up giving us a plot that looked like this. And we found that even if we were to try to make this into a line, there was no way that was going to cross the origin at 0, 0. So if we wanted to pass through the origin, it had to curve. The fact that it curves tells us this is not proportional. So just like we found that the relationship between the diagonal and the area of a square was not proportional, and like really early on when we looked at all of the tiles in a scaling problem, that was also not proportional. Something about area isn't proportional to length. So that was the big thing that we were looking at. We said, no, it is not proportional because the graph curves, showing no constant unit rate. But there has to be some way that we could use information about the circle to figure out the area, because we were able to figure out the circumference. There's a relationship between the radius and the diameter. There has to be some kind of relationship, even if it's not proportional. So we ended class by looking at this and just getting a sense of kind of estimating. If you have a circle whose radius is the same as a square with this side length, so this is r, I wanted to know how many squares do you think it's going to take to estimate, to cover it exactly. And a lot of people did this. They took this square, and they covered it, and found that it took about 4, but fewer than 4 of those squares. Because 4 of them is going to cover it entirely, but just like we saw earlier, you have this extra that you would have to get rid of. So it's fewer than 4. And there's a video that I'm going to link to that shows that it ends up being more than 3, but just a little bit more than 3. So this idea of about 3 squares fit into a circle, if you have the square's radius being the same, or the square's side length being the same as the radius, that's going to be something that we're going to investigate more formally when we come to class on Thursday. Have a great day.